In this video, we will look at how we can search for an element in an array to see if this element exists in this array. And if it exists, we want to get the location or the index of that element. We will also look at how we can copy arrays. And lastly, we will see how we can compare two arrays to check if they are equal or not. So let's start with the search. What we are going to use is actually something called sequential search. A sequential search will look for a value in an array. So this value, we will call it a search key, and will determine if this value exists or is in this array. The sequential search is actually the simplest form of searching, and it's not the most efficient, but it's the easiest one to implement. So the approach we are going to do is we are checking if this element is in the array by checking element by element and comparing this element to the search key. So we start with the first element, we compare it to the search key. If they are equal, then we will return the index of that element. If they are not equal, we'll go to the next element, and we keep going until we reach the end of the array. If we reach the end of the array and we did not find the element in that array, in that case, we'll be returning -1. Why are we returning -1? Because -1 is not an index. Our indices start from 0 up to the length -1. So if we return back -1, that means we did not find the element in that array. So let's look at how we can implement this sequential search in Eclipse. So I'm gonna start assuming that we have this array of integers, and I'm gonna create this array directly in the class. So I'm gonna make it as a static array, so we can have access to it in the main method. And let's make it an integer array, 2 square brackets to indicate that this is an array, and we call it numbers. And I'll assign it values using an initialization list directly. So this is my array numbers. Now again, why did I make it static? Because inside our main method, we can only access static variables from outside this method. Now, same thing, if we want to create a method here and we want to call it directly from the main method in the same class, we have to make that method also static. So let's create our search method. So I'm going to make this method public, static. And this method is going to actually return an integer. This integer will represent the location or the index of the member that we are looking for inside our array. We are going to call this method search, and this method will take an integer that represents the key. So the key is the value we are looking for in our array. So we are searching an array. This is the array we are searching, and we are searching for this key element. Now the element type will be of the same type of the array because we are looking for an integer inside an integer array. Now notice we have this red underline under the name of the method because this method is expected to return an integer, and we do not have a return statement yet. So again, what are we going to return? We are going to return the location of the element key inside our array. So let's create an integer, the one that we are going to return, and let's call it the index, which is the index of the element that we are going to find. We will initialize it with -1. So if we do not find the element inside our array, we are going to return that -1 to tell the user that this element does not exist in the array. Why did we pick -1 again? Because -1 is not a valid index. So when we see -1, we know that this index is not part of our array. So we are going to return this index at the end of this method. So now we do not have this red underline. So what are we going to do now? We are going to iterate through the array elements. And to iterate through an array elements, we use a for loop. We start with 0, the first location, up to the length of that array. So the array is called numbers.length. Numbers.length. And we are going to go up to, or going one step at a time. What are we going to do for each member? So we are going at the first element. We are going to check, does this element match the key we are looking for? So if the element at location I, so numbers at I, if it's equal to the key. In that case, we are going to return I, which means that we found that element at location I. So this is the index of the element. If we did not find it, we'll go to the next element. So we're going to element 1 after that. At location 1, is it equal to the key? If it's not, we're going to the next element. We keep going until we reach that element where the numbers at that location is equal to the key. We'll return it. Otherwise, if we are done with the array and we did not get a true on this condition, we are going to return the original index, which is -1. So if we want to call this method in our main, we can call this method using the name of that method. So search, we are searching, for example, for the value 3. Now this method is going to return an integer, so we can store that integer in an integer variable. Let's call that integer actually index. If we want to print that element, so system.out.print line, we can print the element using the array name, numbers, and the index that we got from that search. Now, since we already know the element, we do not need to actually print that number. We just want to know the location of that number, so we'll just print out the index. So let's actually run this. You'll see that the element with the value 3 is actually at location 2. So this is 0, 1, and this is 2. If we look for the element, for example, 4, we are looking for the value 4 in this array. We'll get the index of that element, which is at location 3. If we try to look for an element that does not exist in our array, in this case, we'll get back -1, which indicates that this element is not part of my array. Now, let's say that we have an array that we want to copy. We do not want to make changes to the original array. We want to copy that array and make changes to that copy. So we want to maintain the original array. We want to have a backup of that array and make changes, for example, to that backup. Now, what we can do, we can try by, assigning or creating a new array. So this is the array. Let's call it Bill's backup. Let's assume we have an array called Bills, and we want to create a Bill's backup array. So this array will have the same size. If we had 6 elements, this new array will have 6 elements. So we are creating a new double array with 6 elements. Now, if we try to do this, where Bill's backup will be equal to the cells Bills or cell Bills, the original array, that will not be correct. Why? Because what you are actually doing here, you are not copying the array elements, you are just copying the references. Remember, this is actually a reference. This is not an object. This is just the reference. The actual data elements were not copied. We only copied the reference. So what will happen now, we have 2 pointers pointing to the same location in the memory, which is not what we want. Why will this be a problem? If you make any changes to this array, this will also affect the original array cell Bills. And that's not what we want when we copy. When we copy, we want to have each copy as an independent copy. So cell Bills will be independent from Bill backups. So we do not want them both to point to the same location in the memory. We want each one of them to have its own place in the memory. So using the equality sign or the assignment operator with the object references or the array references is not correct. What we want to do is actually copy element by element. So the new array at location I, we want it to be equal to the old array at location I, or the original array at location I. So we are iterating from element 0 up to the length -1, and for each element in the new array, we want it to be equal to the element in the old array. So whatever we had here, it will be equal to the value, or this value will be copied in this Bill's backup. So copy element by element, we are not copying the reference of the array. So let's test it here in Eclipse. Let's say that I want to make a copy of this array numbers. I'm going to create a new integer array. And let's call this array copy. And instead of assigning or copying like we had before, let's actually directly make it equal to numbers. Now we will see the problem if we make any changes to the copy or the numbers. So let's say that we want to see what we have in the array numbers, system.out.println, and let's print the value at numbers at location 1. So let's run this code and see what is the value at location 1. At location 1 we have the value 2. Let's do the same with the copy. System dot out dot print line, and let's print the copy at location 1, 2. So the numbers at location 1 we got 2, and the numbers at location copy 1 we got also 2. So it appears like we copied actually the arrays. However, if we make changes to the array copy at location 1, so copy at location 1, let's make it equal to 0. So I made a change to the array copy at location 1 and I made it equal to 0. Now, since we made the change only to the copy, this change should not affect the original array, which is number. However, if you try to go and print the value system.out.println numbers at location 1, you will see it actually changed to the value that we had set in the copied array. So you'll see that we actually changed the value in the original array and in the copied array, which is not what we want. So again, when you copy an array, we do not want to have both references pointing to the same location in the memory. We actually want to copy the elements one by one. So this is not how we actually copy arrays in Java. So instead of doing this, we will create a new array. So copy will be equal to a new integer array. And let's give it the same size of the numbers array. To get the size of the numbers array, we can actually use numbers.length, which returns an integer that represents the length of that array. So both arrays now have the same size. What are we going to do? We are going to copy element by element from the original array to the copied array. So we're starting from I equals 0, the first index is 0, and I is less than numbers.length. And then we are incrementing one by one. We are going element by element in our array. What are we going to do at each element? Our copied array at location I will be copied from the original array numbers at location I. So now we have this array copied. At location 0, we are getting the array numbers at location 0. It will be placed in copy at location 0. Same thing for location 1, 2, 3, and 4. Now what will happen if we make changes to the copied array, that should not affect the array numbers. So if we run this code now, at location 2 or 1 and the numbers array we have 2. At location 1 in the copied array we have 2. If we make changes to location 1 at the copied array, the numbers array will not be affected and we still have 2 in location 1 in the numbers array. So if we run it, you'll see we still have 2 in the numbers array. If we try to print out the copied array at location 1, we will see that we have the new value, which is 0, but in the original array it did not change. So in the copied array we made it 0, but the original array was not affected by this change in the copied array. The last thing we will look at in this video is actually checking if two arrays are equal to each other. Now again, we are not checking the references, we need to check element by element. So what we are going to do, we are comparing the elements of two arrays if they are equal. We will start by checking if they have the same length. If they do not have the same length, that means they are not equal to start with. So we start by checking if they have the same size, and then we will go element by element and check if they are equal. If at any point the element in the first array is not equal to the second array or the element in the second array, we will terminate and say that this array or these arrays are not equal. So we will need to have a flag variable, a Boolean variable, to keep track if the array is equal or not. So anytime we get an element that is not equal to the element in the second array, we'll make that Boolean flag as false to indicate that we found an element that is not equal. So we'll have a for loop to iterate through the elements and then a Boolean flag to keep track if we have equal elements or not equal elements. At the end of this operation, we will check if this flag is true. If it's true, that means the two arrays are equal. If it's not true, that means the arrays are not equal. So again, we are not checking the references. If we use the equality operator, cell bills, is it equal to bills backup? That will just check if they both point to the same location. What we want to do is actually check element by element to make sure that they are equal. So let's try that in Eclipse. I'm gonna create two new arrays here. So integer array, let's call it array 1. And again, you need to have square brackets to indicate that you have an array. And let's assign it values using an initialization list. So 1, 2, 3, 4, and 5. These are my initial values. Let's create another array, integer array 2. And let's assign it also the same values, 1, 2, 3, 4, and 5. So again, we are going to compare if these two arrays are equal or not. So to do that, we will start by checking if they have the same length, if they have the same size. So if array.length or array1.length is not equal to array2.length, that means they are not equal. So if their sizes or lengths are not equal, that means they are not equal. So if we have it here, let's create our flag. So Boolean, call it is equal. And we will start by initializing it to true. So we are assuming at the beginning that these two arrays are equal. So if at any point or before we start checking, if they do not have the same size, my is equal variable is going to be false because they do not have the same size. Else, if they have the same size, we are going to check element by element. So we have a for loop for integer, and then we start by assigning this integer value I equals to 0 to start from the first element, and then while I is less than the array.length, and it doesn't matter which array, array 1 or array 2, because now we know that they have the same size, I'm going to do I++. So we're going to iterate through the elements of the array element by element. What are we going to check? We can have an if statement. If array 1 at location I is not equal to array 2 at location I, in that case, the Boolean variable is equal will be false. So that means they are not, these two arrays are not equal. So we start again with the first element at location 0. Is array 1 at location 0 equal to array 1 at location 0? If they are equal, we are not doing anything. My is equal variable will still be true. We go to the next element, we compare them, go to the next ones until we reach the end of the array. Once we reach the end of the array, we can actually print out the result. So system.out.print line, and we can actually print that is equal flag. So let's try to run this code. We have two identical arrays. Let's run that. We got true because these two arrays are equal. Let's make one of them shorter than the other. So the first one has 4 elements. The second one has 5 elements. So that means they are not equal. So when we check here array1.length, it will not be equal to array2.length. So this variable will be equal to false. We are not executing this loop. We are just printing out false, which means that these two arrays are not equal. Let's have one element different. So the same size. We do not have a difference. They have the same size, but one of the elements is not equal to the second element or to the second array element. So we started comparing one by one. They are equal, so we're moving on. Next one, until we reach the last one. They are not equal, so array 1 at location 4 is not equal to array 2 at location 4. So we set the value for is equal to be false, and then we are printing the is equal, which will be false. So if we run this, we see we are getting false. Now, if we had the first element as false or not equal, so let's say the first element here was 0, instead of iterating through all the elements, what I can do here is I can check for the size and at the same time check for the is equal. So if also is equal here, so while we have array1.length I is less than array1.length and is equal is still true, we are going to check if they are equal. If at any point we made the is equal to be false, we do not need to check the other elements, we just terminate the for loop. So when we checked here, is 0 equal to 1? It's not, so we set the value for is equal to false. Now we went and updated the value of I, so I is now equal to 1. 1 is less than the array.length, but the is equal variable is false. So this whole condition will be now equal to false. Since this condition is false, we are not going to continue with the loop. We are exiting the loop and will be running this line. So now we do not need to check all the elements. We only want to check until we reach the is equal, or we make the is equal variable equal to false. So again, we are checking element by element. We are not comparing references. So the first step, we check if they have the same size. If they do not, we make the is equal false. If they are the same size, we are going to iterate through element by element until we make one element, or find that one element is not equal to the other element, or we reach the end of the array, and then we are printing out the is equal variable.